Alright, welcome back. So we're continuing with integration, this time working with logarithms and exponential functions. See if I can get rid of this toolbar really quick. There we go. So our objectives are to integrate logarithms and exponential functions, and to use integration to determine the average value of a function. So first I'm going to look at our derivative rules. If I derive the natural log of x, I'll get 1 over x times dx. That times dx is because of a chain rule. Same thing, if I derive e to the x, I get e to the x times dx because of chain rule. If I derive a to the x, I get a to the x ln a times dx because of chain rule. So working backwards, I should be able to work from the right side and get to the left side. So if you integrate 1 over x dx, you'll get natural log x plus c. If you integrate e to the x dx, you'll get e to the x plus c. And if you integrate a to the x, you'll get a to the x divided by ln a plus c. This last one's a little bit weird. But when you derived, you multiplied by ln a. So when you integrate, you should do the opposite, which means instead of multiplying by ln a, you'll divide by ln a. That natural log of a is just a constant. So if you integrate it again, you would have a to the x over ln a squared. If I derive
Mr.
this
Brennan, I
again...
can't see your screen.
Okay, go ahead and you can drop Skype and rejoin the call. Try Zoom if you want to. See, I'm showing screen share, so this should be okay. Okay, if at any point it still doesn't work for you, swap over to Zoom. We've got half the people that say Zoom works great, and then I've got a couple people that said Zoom doesn't work at all for them, so it's just whoever your internet provider is, unfortunately. Okay, so if I wanted to find the average value with a set of numbers, you would add all the numbers together and then divide by the number of numbers. If you want to find the average value for a function, we can do kind of the same thing. Okay, so as an example, I'm going to get the average of 2/3 cosine of 2x. From x equals pi to x equals 3 pi over 2. Okay, if I was going to graph that, it would look like this. If I plug in pi right now, that's where the cosine normally is at 2 pi, which is at a high point, times 2/3. So this is 2/3. I'm going to call this pi. And we are at a high point. And then at 3 pi over 2 times 2 is 3 pi. My cosine is normally at a low point, so that's -1 times 2/3 is -2/3. Would be here. So my graph looks something like this, right?
Yeah.
Okay, so what I'm going to do is I am going to integrate this function. 1 over b minus a, so that's 1 over 3 pi over 2 minus pi, which is 2 pi over 2, times the integral from pi to 3 pi over 2 of 2/3 times the cosine of 2x dx. Okay, so I'm going to make a U-substitution where u is equal to what?
U is equal to, should I say two 2x?
2x, perfect. Okay, I'm going to break out of this just so I can zoom. Okay, so it's a little bit too much maybe. Okay, my u was 2x, you said? Oops, it's right in red still. My u was 2x. That means my u prime is what?
2.
Okay, I'm going to say 2 dx, so I know I have to substitute for that dx as well. That's okay. And then that does mean that my bounds are going to change as well, because right now these bounds are x values. I want to change them so that they become u values. So if u is 2x, then what will the lower bound become?
at ux2 dx.
Okay, so this is u at pi will become 2 times my x value, which is pi, or 2 pi, is my new lower bound. Okay, I'm going to do the same thing for my upper bound. I'm going to plug in my x value of 3 pi halves. My function is 2 times x, that's 2 times 3 pi halves, is 3 pi. Okay, so if I want to rewrite this integral in terms of u, this would become, oops, scroll down too far. This would become 1 over, I had on the outside 3 pi halves minus 2 pi halves is pi over 2. Okay, this 1/3 I can pull out because I don't need to use it for my U-substitution. I just need 2 dx. So this 2 and dx will be substituted for. To give me u prime. The 2x is my u. So this will be the cosine of u. My integral is going from my lower bound to my upper bound, which we said was from 2 pi to 3 pi now in terms of u. And then I still have a 1/3 on the outside, and the 1 over pi over 2. What's 1 divided by pi over 2?
1 divided by pi over 2, it becomes 2 over pi, right?
2 over pi. Perfect. If I'm dividing by a fraction, I can flip and multiply. So 1 divided by pi over 2 is the same thing as 2 over pi. Okay, so this is my same integral, but in terms of u. Okay, that's really what you were doing on part 1 through 4 of your homework. You were just substituting to rewrite your integral in terms of u. Okay, do you understand what we did so far?
Yeah.
Okay, so now I'm actually going to solve that integral. This is not what you did on part 1 through 4 of the homework. On part 1 through 4 of the homework, you stopped here and you did not solve. I'm going to keep going and solve. So let me zoom back out. Okay, I can't erase, so I have to leave this 1 over. So this is 2 now on top, 2 times 1 over 3 pi. Times, if I integrate cosine u to du, what do I get?
Oh, wait, can you say it again?
What happens if you integrate cosine?
Oh, it became sine.
Sine, okay? So this will be the sine of u from u equals 2 pi to 3 pi. Or I could say, I'm going to write this over here maybe. 2 over 3 pi times the sine of u from 2 pi to 3 pi, which is equal to 2 over 3 pi times the sine at 3 pi minus the sine at 2 pi, upper bound minus lower bound. What's the sine at 3 pi?
Sine at 3 pi is equal to sine at 1 pi, so it becomes -1.
That would be the cosine.
Oh, sorry. 0.
0. Okay, so this is 0 minus, and then the sine at 2 pi, which is the same thing as the sine at 0.
So it becomes still 0.
Still 0. Okay, so I've got 2 over 3 pi times 0 is 0. So this is saying the average y value is 0. I'm going to check graphically just to make sure that's true. Graphically, we went from cosine's high point, added all of these y values, to cosine's low point, added all of these y values. Would they cancel out?
Yeah.
Yeah. So that's why our average value is 0. because all of these positive y values cancel out with all of these negative y values to give us an average of 0. Okay, so the point of this is, just like when you were getting your average of a number set, you added all your numbers together and then divided by the number of numbers. When we've got a function instead, I'm adding all my y values. That's really integrating. Repeated addition of all of my y values. Which gives us an area. But if I add all of my y values possible together, there's infinitely many y values from x equals a to x equals b. So I got the sum of all of my y values, and then you divide by your change in x. That's your total number of numbers. We went from pi to 3 pi. Gives us an average. The math is the same as what you did with the data set. You added all your y values together. That's this part, the sum of all my y values. And then you divided by the number of y values, which is your change in x. Because this is an average value, your units will not change. So if this 2/3 cosine 2x was really a velocity, and your x value was time, when you integrated, that would have stepped up to displacement, right? But then you divided by your change in x. If you divide your displacement by change in x, you'll get back to velocity. So your units in the end did not change. This would give you your average velocity from pi to 3 pi halves. Any questions on what we did?
Yeah, sounds good to me.
So let's say if I wanted to find the average value of 2/3 cosine 2x from x equals pi to x equals 3 pi over 2. So our function looks something like this. If I plug in pi right now, I'm where cosine normally is at 2 pi. So that would be somewhere up here. And then we're multiplying by 2/3, so this would be a maximum of 2/3. If I plug in 3 pi over 2, this is where cosine normally is at 3 pi, which is 0. So my function looks something like this. Okay, so what integration is really is just repeated addition. So we're finding this area underneath the curve by adding all of our y values together. Oops. Adding all of our y values together again and again and again and again and again until we get the total area underneath the curve. So because integration is really just repeated addition, what I can do is I can integrate, so get that total repeated adding of all of your y values together from our start point to our end point. But then divide by our distance from our start point to our end point in order to get our average value. So that's this formula. 1 over b minus a, so in this case, 1 over our difference from 3 pi halves to pi. Pi is the same thing as 2 pi halves times the integral from our start point, pi, to our end point, 3 pi halves, of our function, 2/3 cosine 2x dx. Okay, again, this integral is going to add all of our y values together. So that's just like if I was going to get an average value normally, you would add all the numbers in your data set and then divide by the number of numbers. I'm dividing by the total distance, the total x values that we added together to get my average value of this function as we go through. So if I integrate this, To get a cosine of 2x, I would have to derive a sine of 2x. And then I would multiply by 2. So this is my u is 2x, therefore my u prime is 2 dx. So if I substitute, this would be the cosine of u. And then my 2 dx would cancel. I'd be left with a 1/3 that I could pull out. I'll substitute 1 over pi over 2 times 1/3 times the integral of the cosine of u prime. U prime is the 2 and the dx. If u is 2x, then this would go from 2 pi to 3 pi now. That's 2 times pi and 2 times 3 pi over 2. Okay, so if I integrate that, if I integrate cosine, in order to get to cosine, I would have to derive sine. So I would get the sine of u from 2 pi to 3 pi. Okay, so if I plug that in, that'll be the sine at 3 pi minus the sine at 2 pi. Okay, then I've got all my constants that are on the outside here. 1 divided by pi over 2 is 2 over pi times 1/3. So that's 2 over 3 pi times all of this. 2 over 3 pi times all of this. Okay, the sine at 3 pi. My sine at 3 pi is 0. My sine at 2 pi is also 0. Pi, 2 pi, 3 pi. Alright, where did I go wrong? I had cosine 2x, that's fine. My u is 2x, u prime is 2 dx, okay. That's fine too. When it integrates cosine, I get sine, that's fine. This is fine for my bounds. U is 2x, my x was from pi to 3 pi over 2. So that's 2 pi to 3 pi. I don't see where I went wrong for this sub. Okay, if you see it, help me out. I've got u is 2x, that's fine. U prime is 2 dx, that's fine too. Just doing 2/3 of cosine 2x from pi to 3 pi halves. Maybe my picture's wrong. I had the cosine of 2 pi. Cosine at 2 pi should be 1, so that should give me 2/3 is here. The cosine at 3 pi over 2 times 2 is the cosine at 3 pi. Cosine at 3 pi should be -1. That's where I went wrong. Okay. With my graph, not with my integral. There we go. So I'm adding all of these areas together and it'll look like this. I guess this is what I get for picking a new function off the fly, but okay, so my average value, this is 0 minus 0 times 2/3 pi is equal to 0. And my average value is 0 based on my graph. Okay, the key point here is that my units did not change. So I integrated. So if you want to think of my original function, this 2/3 cosine as velocity, When we integrate, I would get to displacement. Then I divided by my change in x. If you divide your displacement by your change in time, you would get back to velocities. If you want to think of this in terms of physics, my units have not changed by the time you get to the end of this. Okay, versus my average slope, which is just my algebra version of slope, y2 minus y1 over x2 minus x1. My average slope does change my units. If you started with velocity, your slope of velocity would give you acceleration. It's different from your instantaneous slope, which is your derivative. Your instantaneous slope gets a slope at a single point, where your average slope is an average. Okay, I'm going to go back. Any questions on anything we did for average value or average slope? Okay, can you guys hear me?
Wait, on the left side, like where it says like the something like, how do you call the thing that something looks like E? It's on the top left thing.
Just move the zoom window. So you mean this one here?
Yes, yes.
Okay, that's sigma. That just means the sum.
Oh,
So normally an average means you would sum all of your values together and then divide by the number of numbers.
okay.
That's really what we're doing here, only instead of having a list of numbers, we've now got a function. So to sum up all of the y values, what we can do is integrate.
Okay.
Okay, then we divide by the number of numbers, which is divided by our upper bound minus our lower bound. Should give us the space between them. Okay, good question. Anything else on this slide?
No.
All right. So I'm going to try a couple first. These first couple are just integrating with our new logarithm and exponential rules. And then we'll go and we'll try an actual AP Calculus problem that has some average value, average slope stuff. So we'll see where this eventually goes. So for this definite integral, what is my inside function, do you think? So if I want to do a U-Substitution, what would U be?
2x plus 2.
2x plus 2, that's perfect. So then my U prime would be my derivative of 2x plus 2, which is 2dx.
Not 4x. Oh, sorry. I thought that's a 2.
Okay, so it's 2x to the first power. That might be my handwriting again. So 2x plus 2. If I divide 2x to the first power, I'll get 2dx. So if I want to rewrite this function, I would need a 2dx in order to substitute for u prime. I don't have a 2dx. So I'm going to multiply by 2 and divide by 2. And that will give me the 2dx that I need to substitute for. Okay, then I can rewrite this. So this will be, instead of the integral from -6 to -3, so x plus 2 of 2dx times 1/2. And I've got that extra 2 and that 1/2, which does not change the problem, but I needed a 2dx to substitute. When I substitute, this will be 1/2 still on the outside. I'll have a -3 still on the inside, but this 2dx will become u prime. And this 2x plus 2 will become u to the first power. Okay, my bounds will also change. U at -6, that's my lower bound, will become 2 times -6 plus 2, or -10. U at -3, that's my upper bound, will be 2 times -3 plus 2, or -4. So I've got -10 to -4 now. Okay, and then with our new rule for today, if I integrate u prime over u, what should I get?
Sorry, can you repeat?
What happens if I integrate u prime over u? It's a new rule from today. What would I have to derive in order to get 1 over x?
Ln?
Natural log x, okay. And then if x was a function, that would be 1 over x times x prime. So in order to get 1 over u times u prime, I would have to derive a natural log of u. Okay, so this negative 3 is a constant, so I'm going to pull that out. This will become negative 3 over 2 on the outside. On the inside, I just have 1 over u times u prime, which will become a natural log of u. So that gives me negative 3 halves that I had on the outside, natural log of u, from negative 10 to negative 4, because we had bounds. Okay, this is already in terms of u, so I can just substitute straight in. So this is negative 3 over 2 times the natural log of negative 4 minus negative 3 over 2 times the natural log of negative 10. Okay, I'm subtracting a negative, so that's the same thing as adding a positive. You know what? I think I'm just going to substitute this out, actually, so that'll be easier to see. So I'm going to factor out this negative 3 over 2. Negative 3 over 2. That leaves me with the natural log of negative 4 minus the natural log of negative 10, which for my properties of logarithms means I can combine these. That's the natural log of negative 4 over negative 10. Or the natural log of 2/5 times negative 3 over 2. Negative 3 over 2 times ln of 2 over 5, if I simplify, is our final answer. Any questions on what we did?
No.
Okay, that last part was a little bit tricky. I'm going to do that last step one more time. What I did was I factored out that negative 3 over 2 from both sides. That allowed this first part to be positive now, and this second part will still be negative. So that's ln negative 4 minus ln 10, and then with my properties of logarithms, if I'm subtracting with the same base, I can divide. Okay, then I simplified to get my final answer. Okay, one more. For this function, someone other than Abby, since I've heard from her 2 or 3 times now, what would my u be?
I think u is just 3e.
Okay.
2x minus 4.
Okay, my u would be the 2x minus 4. If I try to substitute for the 3e, I'm not actually raising the 3 to the 2x minus 4. So I would run into a problem when substituting for all of this, because I'm not actually doing the same thing to the 3 as I am to the e. Okay, so my u is 2x minus 4 is that power. That means my u prime would be 2 dx. Okay, the other problem
So we take the power, not the value itself?
Right. I'm substituting for this power. If you substituted for, I could substitute for e instead, but if you substitute for e, then when you derive it, you'll get 0. So that wouldn't help me replace this dx. Would be my clue that I need to try something else. Okay, so I'm going to stick to this. U is 2x minus 4, and u prime is 2 dx. I don't have a 2 dx, so again I'm going to multiply by 2, and if I multiply by 2, so that I don't change the original function, I'll have to divide by 2. Okay, so if I substitute now, this 3 can be pulled out, so this will become 3 over 2. If I substitute 0 in for my lower bound, u at 0 will be 2 times 0 minus 4, or negative 4. U at my upper bound, that's 2, will be 2 times 2 minus 4, or 0. So this will be my integral from -4 to 0 of e to the u power times u prime. Okay, so that's u is 2x minus 4, so this is e to the u power, and then u prime is 2 dx, so 2 dx is u prime. Okay, any questions on my substitution?
No.
Okay, so I'm going to integrate. What happens when I integrate e to the u prime?
Sorry?
What happens when I integrate e to the u times u prime?
It's itself?
It's itself. Okay, so in order to get e to the u, I would have to derive e to the u. Okay, so this would become 3 over 2 times e to the u from u equals -4 to u equals 0. Or 3 halves times e to the 0 power minus 3 halves e to the -4th power. Okay, which I could rewrite. Anything raised to the 0 power is 1, so this is 3 over 2 times 1 minus 3 over 2 e to the 4th power, because if you have a negative exponent, you can move that to the bottom of a fraction. Okay, if I really wanted to, I could get a common denominator here. This fraction does not have an e to the 4th power on bottom, so this would be 3e to the 4th power over e to the 4th power. Oops, sorry, 2e to the 4th power, I already had 2 down there, minus 3 over 2e to the 4th power. Okay, now I have a common denominator, I can subtract straight across. This will be 3e to the 4th minus 3 over 2e to the 4th as our final answer. Any questions on this one? Nope. Okay. So that was logarithms and exponents. I'm going to take a look at one word problem. So what I have here are temperatures in degrees Celsius of water in a pond every 3 days. So every 3 days we went on and measured. I want to use this first to get an estimate for what the change in temperature was on day 12. That's my derivative at day 12. Okay. Any ideas on what I could use to get an estimate for the derivative if all we have is this data from a table?
We could create like a function based on the points we have.
Okay, we could try to create a function based on the points. I don't really have a function here. So if I did that, I would have to use some form of linear regression, and I would be guessing. So that's okay, and I like that answer. But we can do something faster. What is a derivative? What does it mean?
Basically finding slope.
Finding slope, okay.
Something.
So if a derivative is slope at a point, how could I get an estimate for the slope using this table? I want an estimate for the slope at 12. What's another formula for slope?
Y equals mx plus b.
Okay, that would allow me to find slope only if this was a line, and we can see that this isn't a line because I'm going up and down. What's another formula for slope?
Rise over. No.
That's okay. Go.
Rise over run.
Rise over
Or run over.
Okay, what's our rise?
WT, I guess.
Okay, so my change in y, in this case WT, over my change in
T.
t. Okay, that's perfect. So that means we can estimate our slope using y2 minus y1 over x2 minus x1, basically. Again, this is an average slope. It's not the slope at one point. So this is just an estimate. So that I have 12 inside that range, I'm going to make my estimate w at 15 for my y2 and w at 9 for my y1. So that means my t's will be 15 minus 9. Okay, w at 15 is 21, minus w at 9 is 24, over 15 minus 9 is negative 3 over 6, or negative 1/2 is my estimate for slope. Okay, here it is again. W at 15 minus W at 9 over 15 minus 9 is 21 minus 24 over 15 minus 9, or negative 3 over 6 is negative 1/2. Okay, I'm going to erase this so we've got room. And we'll flash answers. There we go. Any questions on this one? Okay, again, we're just estimating. Because derivative is the slope at a point, a derivative is an instantaneous slope. So the slope at exactly 12 is sort of the perfect answer that we are estimating. If I want to get a quick estimate for it, using data from the table, then we could do a quick estimate for slope using our algebra form of slope, which is y2 minus y1 over x2 minus x1, where our y values are wt and our x values are t. I know that wt is my y values because it's taking an input. Y is always an output. X is always an input. So in function notation, this is y of x equals whatever our formula is. So a formula could be anything, x squared. We don't really know what the formula is, but my input would be here, and I would end up with an output. Okay, any questions on part A?
No.
Okay, what are my units? So we found the slope of WT. So if W...
Celsius.
It says Celsius. Right?
Okay, WT is in Celsius. We got W prime T. So what
Oh,
would the,
Fahrenheit?
not Fahrenheit, no. WT was measured in degrees Celsius. So what would my slope be measured in?
Celsius per day.
Celsius per day, there we go. Degrees Celsius per day. Okay, again, a slope is a change in y over change in x. So if we look here, if my slope is change in w over change in time, that would be change in Celsius over change in day, or Celsius per day. Okay, any questions on units? Okay. Then the new stuff. For part B, I want to estimate the average temperature over the interval from 0 to 15 using a trapezoidal approximation with subintervals of 3 days. Okay, so we had a new formula for today that said our average value of a function was 1 over b minus a times the integral from a to b of f of x dx. So that means my average temperature would be the total amount of days that have passed, so that's my upper bound to lower bound, or 1 over 15 minus 0, my change in days, times the integral from 0 days to 15 of wt dt. So what that's going to do is that's going to add all of my temperatures together from 0 to 15. And then I will divide by 15 to get my average temperature across these days. Okay, is everyone okay with our setup so far? Okay, now we don't have a function to integrate, so we were told that we should estimate using a trapezoidal approximation with subintervals of 3 days. So what that means is if I go graph this from 0 to 15, make a little bit straighter line there. Okay, I don't know if that's too much straighter, but from 0 to 15, I've got subintervals of 3 days. So that's 0 to 3, 3 to 6, 9, 12, and 15. I'm going to create trapezoids out of this. So I've got heights at 20 and 31 would be my first trapezoid. 31 and 28 would be my second trapezoid. 28 and 24 would be my third trapezoid. 24 and 22. And then 22 back to 21. So I've got something that looks like this, where we can get the areas of all of these trapezoids and add them together to estimate the area underneath the curve. So I still have my 1 over 15 that I have on the outside, but I'm going to multiply by my trapezoidal approximation, my trapezoidal Riemann sum, with subintervals of 3. So that's the area of a trapezoid is equal to the average of my heights times the bases. Okay, my base is 3 for all of these. So my first trapezoid would be 3 times the average of my heights, which would be 20 and 31. Okay, then my next one, still 3, so my distance of 3 for this second one, times my heights of 31 and 28. Okay, my next one, still a base of 3, with heights of at 6 and 9, so that's 28 and 24. Okay, another base of 3 with heights at 24 and 28 for my next trapezoid. Sorry, 24 and 22. 24 plus 22 over 2. Okay, and my last one, still a base of 3 with heights of 22 and 21. Okay, any questions on our trapezoidal approximation? Okay, then I'm going to factor out everything I can. Every single term is being multiplied by 3 over 2 right now. So to make this easier, I'm going to factor out that 3 over 2. So this is 1 over 15 times 3 over 2 times 20 plus 31 plus 31 plus 28 plus 28 plus 24 plus 24 plus 22 plus 22 plus 21. Okay, I hope I didn't make any adding mistakes. Any questions on my setup?
No.
Okay. So my 3 and my 15 can cancel. So that leaves me with 1 over 10 on the outside. And then on the inside, I'll add all of this together. So I've got 51 plus 59. I'm going to throw the 1 over to the 59, so that's 60 plus 50 is 110. This 46 and 43, I'm going to throw the 3 over to the 46. So that'll give me 49 plus 40 is the same as 89. Okay, then I've got 52 plus 89. I'm going to throw 1 over to the 89, so that'll be 90 plus 51 is 141. So I've got 141 plus 110 is 251 divided by 10 is 25.1. Okay, any questions on what we did?
No.
Okay, I'm going to throw their answer over the top of this. So you can see that. Okay, same idea. So your average value is 1 over b minus a, that's 1 over 15, times our estimate for our integral, which is our trapezoidal approximation, which is half of the average of my heights times the base for every problem. We add them all together to get 1/10 of 251, which is 25.1. Okay, my units are degrees Celsius. Running out of space. Degrees Celsius. Again, because my average value does not change my units. So I started with degrees Celsius. I integrated, so I'd get up to a new unit, but then I divided by time again. So this would have been degrees Celsius times time divided by time still gives me degrees Celsius. Okay. For part C, I am told that we have a new function, pt equals this, which is a model of my temperature in the water. I want to find out what the derivative would be, and then explain the meaning in terms of water temperature. Okay, so if p of t is 20 plus 10t e to the negative t over 3, what would my derivative be? P prime at t. Okay, I'm going to pull from somebody from Zoom just because I haven't heard from any of the Zoom people yet. So let's go Kyle. What happens when I derive PT right now? Oh. Okay, that's why I can't hear anybody from Zoom. I'm going to turn you way up. Can you say it one more time?
So 20 will cancel out, so it'll be 10e to the power of negative t over 3.
Okay, 10e to the power of negative t over 3. This is product rule.
Yeah.
Product rule, so I've got an f and a g. So you derived this. This is f prime is 10 times g, e to the negative 2/3. Okay, what should come next? Okay, plus f 10t times, what's the derivative of g?
Itself.
Okay, itself e to the negative 2/3, and then chain rule times If I derive e to the x, I get e to the x dx. So if I derive e to the negative t thirds, I would get e to the negative t thirds times what? Negative 1/3, that's it. Okay, so that's the derivative of my power. The derivative of 1/3 times t is 1/3. And that was negative, so derivative of negative 1/3 times t is negative 1/3. Okay, so that's my derivative. And then I need to plug in 12. So p prime at 12 is equal to 10 e to the negative 12 over 3 is negative 4. Plus 10 times 12, 120 e to the negative 4 times negative 1/3. Or I've got an e to the negative 4 on both sides. I've also got a 10 in both sides I can pull out. So this is 10 e to the negative 4 times 1 minus 120 divided by negative 1/3 is 40, and then I've pulled out the 10. Maybe we should have done that in 2 steps instead of 1. But 120 divided by negative 1/3 is negative 40. So I'd have been left with negative 40 e to the negative 4th here. So I've got 10 e to the negative 4 minus 40 e to the negative 4 is minus 30 e to the negative 4, if you want to think of it that way. I factored out, I probably didn't need to do that, but negative 30 e to the negative 4 if I multiply this out. Okay, what are my units right now? If I derived p. Okay, we were told PT was measured in degrees Celsius. So what is the derivative measured in?
Degrees Celsius per second or per minute?
Really,
Per days.
per day, perfect. So degrees Celsius per day. But you're right, it's Celsius over time. Okay. Now we have not learned how to integrate the rest of this function for part 2 yet. So I'm going to write out what my general form would be, and we're not going to solve it yet. Or rather, I might solve it in the calculator instead. But this says, use function p to find the average value of p over the time interval. So we said our average value equation is 1 over b minus a times the integral from a to b of f of x dx. So my average value of pt for our interval from 15 to 0 days, from 0 to 15 days, would be my upper bound minus lower bound. So that's 1 over 15 minus 0 times the integral from 0 to 15 of pt dt. And then I could plug that in. Now, because I have not learned how to integrate this part yet, because I've got a 10t and an e to the negative t over 3, so my u is not the same as what I would need to substitute for u. I am going to integrate this in the calculator. Okay, so if you hit math, and then you go all the way down to your 9th option down is function integrate. Integration takes 4 arguments. You need to know what your equation is. That's my p of t. You need to know what your variable is. So I'm integrating in terms of t. And then you need to know your lower bound and upper bound. So this is my equation. 20 plus 10t. I'm going to write x here because this is just a variable. Times e raised to the negative x over 3. I'm going to integrate in terms of x from a start point of 0 to an endpoint of 15. Should give us our integral, which is 386.362. 386. Oh, there we go. 386.362. What should my units be for this, if this is an average value?
Average change.
So PT was already measured in Celsius.
Is that a 6? Like 386 and 362?
Yes. I can't erase, so I'm just going to rewrite 386.362. I want to know what my units are, though. Okay, PFT was originally measured in degrees Celsius. I integrated in terms of time, so that means I would have multiplied by time. So that would be Celsius times time. But then I divided by how much time had passed. So I had Celsius times time divided by time would give me degrees Celsius. Your average value equation does not change your units. So this gives me my average degrees Celsius over the course of these 15 days, or my average temperature. Okay, any questions on anything we did today?
How much questions for the homework will we have?
I believe you have 2 word problems that I've cut, so it's sort of just like we did here, just like this, where you've got part 1, part 2, and then you've got 8 CUDA-generated problems that are only the logarithm or exponential integration problems. That will be due on Tuesday of next week.
Oh, okay.
I have been told that people are taking a lot longer on the previous homework that was due today than I was expecting, so I'm going to take that through Friday. So that was the one that had 24 problems on integration. If you're not sure about anything, please ask me questions through WeChat or set up another Skype session with me and I can help you out.
Okay, thanks.
Okay.
Just a reminder again, grades for this quarter are ending on Friday. I'm going to be messaging you either tonight or tomorrow if you've got any incomplete still that are in the gradebook. It is possible if you sent me work through WeChat that it's sent to my phone instead of my computer if I wasn't on my computer at the time. So I have had people say I've got an incomplete in gradebook and they just messaged me, I found it on my phone and I was able to update. So I'm going to message everybody just telling you I have everything or I'm missing X and Y so that you can get it into me. I can still change grades through Thursday of next week, but after Thursday of next week, it's frozen for me as well, so I can't change. And then on Friday, you guys should receive your report cards. Both you and your parents should receive it by email, I believe.
Oh no.
All right.
Will course site link be created for that assignment that I was supposed to do today, but postponed on Friday?
I'll create it, yeah. I believe course sites is
Should
up
I
right now.
upload it in case? Because I sent it
You can do
via
that
WeChat.
you can do that if you want to be safe, just because WeChat's a little bit unreliable as far as sending files.
Okay.
I'll have the course sites there as backup. Okay, any other questions?
No.
Okay, I heard Kyle. Kyle, what's up?
Oh, so just to confirm, this homework is due next week.
Yes, the homework for this assignment today, I'm going to take on Tuesday.
Not Friday.
Not Friday, no.
Daddy,
I want to give you the extra day for the word problems.
Oh, I thought if. Oh, sorry.
So I want to give you the weekend for the word problems because I know people are going to have questions. And I'll have more
So
time to
is
answer
it
it in the weekend.
two separate things? It's like two separate documents.
There are 2 separate documents for the homework today. You've got one document that is all the word problems, and then one document that's all of the non-word problems.
Okay.
I'll flash that really quick. So I just posted to the WeChat, I believe, right before this. Oh, it actually didn't send. Okay. So I've got one document that says integration and derivative word problems. And another document that says integration with logarithms and exponents. Homework. So this is your non-word problems. Then you've got another Word document that is excerpts from an AP Calculus exam. But I've cut the parts that we don't know how to do yet. So it's like 2 problems, but you're only doing half the problem.
Does this have a document version?
It does not, but I can make one. I'll make one and send it to you after this.
Okay, thank you.
Okay, thanks.
All right, we are way over time. I apologize. But thank you very much for coming, and I'll see you guys again on Friday.
See you.
Bye.